Okay, so here we have an example of calculations from equations, but using molar volume. So we've been given a balanced chemical equation, therefore we can use the relationships between the species in the equation to work out any unknowns. So the first thing I'm going to do, as with most higher calculations, is to write down the information that I have from the question. So we're being asked for a volume of hydrogen. So that's our unknown. We've been given a volume for sulfuric acid. And we've also been given a concentration. Something else that we've been given that we'll come back to is the molar volume here. So, first thing I'm going to work out is the number of moles of sulfuric acid. And that's using the C times V relationship, concentration times volume. So my concentration, 0.5, and my volume I need to change into litres, so that becomes 0.02. So I've just divided 20 by 1,000 there. So the number of moles is 0.01. Then if I take my sulfuric acid and my hydrogen, now they react in a 1-to-1 ratio. So if I have 0.01 moles of sulfuric acid, I also have 0.01 moles of hydrogen. What I can then do is I've been asked to calculate the volume of hydrogen, and that's where the molar volume relationship comes in. So if we take that molar volume, 22.4, what that literally translates to is for every 1 mole of gas that occupies 22.4 litres. Now I don't have 1 mole of hydrogen, I have 0.01 moles. So what volume does that occupy? And just with any direct proportion, you do the same. So divide up, multiply across. So 0.01 divided by 1 times 22.4, and that comes out as 0.224 litres, or 224 cubic centimetres. Okay, so here is another example of calculations from equations using molar volume. This one is slightly different because we use the molar volume relationship at the start of the answer. So, first of all, I'll write down the information from the question. So we've been asked to calculate a mass of calcium carbonate. So that's our unknown. And we've been given a volume of carbon dioxide. And we've also been given the molar volume, which we'll use in a second. So it might seem on first glance that you don't have a lot of information, which you don't really, but because we have this molar volume relationship, it allows us to work out the number of moles of carbon dioxide. So we do this using direct proportion, as you'll have seen in my previous videos. So the molar volume, 22.4, tells us that 1 mole of gas occupies 22.4 litres. But we have 2.8 litres of carbon dioxide. Therefore, how many moles do we have? So we work this out just like any other direct proportion that you'll have seen before. So divide up and multiply across. So 2.8 divided by 22.4 times 1, and that gives us our number of moles as 0.125. So that's number of moles of carbon dioxide. Then, because we have the balanced chemical equation, we're able to use the relationship between the species and the reaction. So we can take our calcium carbonate and our carbon dioxide. They react in a 1-to-1 ratio. So if we have 0.125 moles of carbon dioxide, We also have 0.125 moles of calcium carbonate. Final thing we then need to do is to work out the mass of calcium carbonate, so that's our unknown. So our mass is our number of moles times our GFM. Gram formula mass I'll just do over here. And those values I've just got from the data book. So number of moles 0.125 times 100.1. So my mass is 12.5 grams of calcium carbonate.